So it's the beginning of July now, and the roses at the rosarium are in full flower, but this marks a break, more or less, in the flowering in the heather garden. All of the Erica carneas are long since over, and the later flowering Erica cinerea and tetralix is yet to kind of kick in, but we do have a few less conspicuous, perhaps, species which are more or less filling the gap. But you have to look a bit more closely to really see that. This is the only European species that is clearly pollinated by the wind. All of the other ones that we've seen so far have got bright, colourful, insect-attractive flowers, and they offer a reward to insects that come and pollinate them. And this is an effective means to make sure that your pollen is transferred to another individual. With a wind-pollinated plant, this is a very different matter, of course. Instead of a precision transfer of pollen, we're casting the pollen out into the wind, and various adaptations allow this to be effective. One, of course, is that the pollen no longer is sticky, that it will transfer in the wind and won't stick to itself and to other things. Another is to produce a large receptive stigma, a surface that can also be stuck out into the wind and will collect those pollen particles as they float by. And Erica scoparia here has both of these adaptations clearly. If we look closely at the flower, and we're going to have to get our hand lenses or macro lenses out to do that, then we can see the details of this diminutive flower in their full glory. As I said, this is the only European species that is clearly wind pollinated, but there are many species, for example in the Cape and particularly in Madagascar, that have the same adaptation. And these are distantly related one from another, which immediately tells us that this adaptation to this different pollination mechanism is important enough that it has evolved independently. We're going to move from Erica scoparia here across to the other side of the heather garden, where there is another species in full flower right now. This is the Balkan heath, Erica spiculifolia, and it exhibits some of the same adaptations that we can see in Erica scoparia, and yet, as you will see, it is brightly coloured, a very apparently typical insect-pollinated plant. And here it is, Erica spiculifolia, the Balkan heath, and as you can see, even at a distance, this is a brightly coloured pink flowering Erica species, but if we look a little more closely, then we'll see that it has large prominent stigmas sticking out. They're not expanded at the end like a typical wind-pollinated species, and you will see visiting insects, but it does not have any nectaries. There's no nectar produced, and on a nice day, and I don't think we're going to achieve that here, when you shake the flowers, you'll see a cloud of pollen coming up. This is a crucial adaptation to wind pollination. The first, most crucial step: if the pollen is sticky, wind pollination isn't going to work. But that is not to say that this strangely brightly coloured, apparently attractive plant is in fact wind pollinated. It's tempting to look at a flower and to think, this has bright colour, or lack of colour, or expanded stigmas, or loose pollen, and to say this necessarily means that the pollen is transferred in a particular way. To actually find out what is the effective vector for the pollen takes a little more research. We could go one step further and think, if certain important adaptations are already present, that the next adaptations, for example, a loss of this bright colour, because most wind-pollinated plants stop expending energy in producing larger, brightly coloured petals, for example. But it would be a mistake to assume that this species was on that road, so to speak, going towards a particular destination, towards a typically wind-pollinated plant. It is not necessarily the case. What we can see here is that this species functions. It works just as it is now, and whatever process, whatever changes happen in the future, who knows? Evolution doesn't go towards a particular goal. Which is not to say that the same goal isn't achieved multiple times independently. Now that is interesting. So with wind pollination, for example, we have multiple different independent examples. We can begin to look at the different circumstances under which this phenomenon occurred and start to attempt to model or to generalise about what those circumstances were, and to draw some conclusions that we think might apply more broadly.